Hey, what's up, you guys? Welcome to another episode on the Incredible Academics YouTube channel. Guys, today today is the 30th of January 2024, right? So we're recording this, and the time is 6:38 in the morning. All right, so today we are looking at some fun and interesting grade 12 stuff, right? And I'm hoping that you guys are going to be able to read. So we are on page 162. That's classroom mathematics, page 162. And I'm gonna go through the question. So in the given diagram, AD is perpendicular to the horizontal plane ABCD. So ABCD, no, it's BCD. So B, C, and then D. Now, when they say it's a horizontal plane, what they're basically saying is that this is literally on the floor, right? That's literally on the floor. So that's what they mean by that. It's on the floor. Although when you're looking at it on the book, it doesn't look like it's on the floor, right? But you must assume that, okay? And we're being told that AD, right? AD over there is perpendicular, all right? So now AD is perpendicular to that. And then let's look at what else they said. They said DC is equal to X meters, right? There's our DC over there, so DC. There's the X. You guys might not be able to see it, but yeah, that's the X over there, the DC. And we've also been told that DBC is close to our beta. DBC. So that angle over there, that's beta. And DCB, the angle, is close to alpha. So DCB, the angle over there, that's alpha. All right. And the angle of elevation of A from B. Right. The angle of elevation from of A from B. So they're talking about this angle here. So everything is already given. Now we're being asked to find the length of AD, right? X sine of alpha. We need to show that the length of AD is equal to that. So, sorry, guys, remember we spoke about the link method, okay? We spoke about the link method. You're going to identify the triangle in which your AD lies. And once you've done that, what you're going to do is you're going to say, okay, you're going to say, okay, fine. Then you can do what? Once you've done that, then you can start finding the corresponding lengths, all right? In other words, you're going to ask yourself, okay, in the other triangles, other than the triangle in which AD lies, how can I find the length of AD, right? The length of the other sides using the other triangles. So I want you guys to understand what I mean. So let's first identify where AD is located. You can see this is our AD, right? That's our AD, okay? That's our AD. So, but in order for us to find AD, you guys know that with sine and cosine rule, you need to have at least two sides and one angle. Do you understand? So in order for us to find the expression for AD, we might want to use this triangle here to find the length of this side, okay? And once you've got the length of this side, then we can probably use that, right, along with the angle over there, right, along with this angle here, to find what? To find our AD. Okay, so the key here is to start off by operating in the triangle other than the one where our AD is located. So enough talking, let's get down into it. So now we're going to check. We need to find the length of the triangle BD, right? I mean the length of the side BD. I hope you guys can see the BD. I mean, by the look of things, you guys won't be able to see exactly what I'm talking about. I'm just gonna redraw this so that you guys can see what's going on. Looks like some kind of butterfly. So this is alpha, this is beta, this is theta, and we've got A over there, we've got D here, we've got X here, we've got C here. You guys probably can't even see what I'm talking about, but hey, I'm just redrawing that diagram so that you guys can see properly. Yeah, you see what I'm talking about now. Okay, so now everything is all clear. All right, now everything is all clear. So what I want us to do is, because remember we've been asked to find that. Okay, we've been asked to find the length of AD. Okay, but to find AD, we first need to find what BD is, right? BD, to operate in this triangle here, very easy. But the length of BD, that's what we might have issues with, okay? And remember, it's going to be easy for us to find BD, right? It's going to be easy for us to find BD. Why? Because in this triangle here, using this triangle, because in this triangle you will really have the length of this, and most of the angles are actually already, already given. So if we say, okay, x over the sine, I hope you guys can see, x over the sine of beta is equal to BD over the sine of alpha. Therefore, BD becomes x sine alpha over the sine of beta. Then we've got our BD. Okay, we've got our BD. But now we can go right ahead and then try to find what's this? Because because remember BD belongs into both triangles. It's actually the link. Okay, it's the link. So when we say link method, you find the side which connects two triangles using one triangle, and once it's been found, right, use it in the other triangle. So that's the link, right? The side which is common, once you find its length using the other triangle, and we can see that now we've just used, let's say this is triangle 1, this is triangle 2, we've just used triangle 1 to find the length of BD. Now we are going to use BD in triangle 2, because we know that BD belongs to both triangle 1 and triangle 2. Do you understand? So we've got BD. So now what we're going to do is we're going to say, okay, fine, we know that AD over BD, right? We're in triangle 2 now, right? We're in triangle 2. AD over BD. that is just the tangent of the angle theta. Okay, and we already know what BD is. So AD over BD, which is the whole of that. Okay, so we're just going to plug in the whole of that. X sine alpha sine beta, which is equal to what? Tan theta. Okay, so now we take this whole thing over here, we do the we multiply with the multiplicative inverse, right, on the left and on the right. So AD becomes X sine alpha tan theta, right, divided by sine beta. Now we need to check if this is the same as what we are asked to prove, right? X sine alpha tan theta sine beta. X sine alpha tan theta over sine beta. So we've got the same answers. All right. So that's how you prove these type of problems, you guys. That's how you prove these type of problems. The issue that I'm having is that these drawings here are so small, you know, and if the drawings are so small, that means you guys are gonna have, you know, difficulties with seeing what's happening. So but let me stop complaining and just redraw quickly. Sorry about that. I'm just trying to redraw here. We'll be done within a couple of seconds. But you guys, I want you to bear in mind the link method. Okay, we find one side using what you identify a common side, you find it using another triangle with the intention of using it in the other triangle. Do you understand? So that is essentially the link method. So here's a diagram that I've just sketched. Okay, and according to me, this is way much better than what's here, right? That looks a bit smaller. Okay, but let's see what we're being asked. All right, so we are asked to prove that CD is equal to K, the sine of beta, sine of alpha. So I'm just going to write it down. Prove that CD is equal to K sine beta over sine alpha tan theta. So this is the situation, all right? K sine beta. So look, whatever they are asking you to prove, just check. Okay, is it a common side? And what is the link? What is the linking side? Which side links, you know, triangles here? And you can see that AB, BC, BD, those sides are actually linking triangles. BD links triangle 1 and triangle 2, and then there's 3. AB links triangle 2 and 3. Okay, triangle 2 and 3, and BC links triangle 1 and 3. So those are the links. Okay, in other words, if you find the length of AB in triangle 2, you can actually use it in triangle 3. If you find the length of BD in triangle 1, you can actually use the very same length in triangle 2, so on and so forth. Okay, so now that we have drawn everything, we need to prove that CD is equal to that. So let's see where CD is located. Okay, you can see that this is our CD. Okay, this is our CD, and the triangle that we are looking at, the triangle 1. Okay, so the problem with triangle 1 is that it doesn't really have any lengths. Okay, in other words, there's no X for BC or Y for BD. You know, these lengths are kind of unknown. Okay, so that's the problem that we're having here, right? So now what are we gonna do? Okay, so I'd suggest that we focus on the links. You see BD and BC, those are links. But instead of focusing on triangle 3, I would actually focus on triangle what? 2. Why? Because in triangle 2, can you see there's a given angle which is theta, and there's also a given length which is K. Okay, so if we can find BD in terms of, in terms of the theta and the K, I think that would be, you know, a good start. So we're going to say, okay, fine. So now we are headed for BD. Okay, we want to find BD. So we're going to say, let me see if we can actually find our BD, right? Because I feel as if in order for us to find the BD, we must already be having that angle over there. Okay, that angle over there, but unfortunately we don't have. All right, we don't have. But let's go back to our information. Maybe we might figure something out. So they're saying, so we're by number 3. So AB is, I hope you guys can see. Let me just lift this up a little bit. AB is a tower, K meters high, and the foot of the tower B is in the same horizontal plane as C and D. So here's our tower AB, right? And you can see that even here they've shaded this. So if this is shaded, you know what that tells you? It tells you that this is the ground, and the ground and the AB, they must make a 90 degrees angle. You see here the 90 degrees angle was indicated, you know, that the tower and the ground, they make an angle of 90 degrees. But unfortunately here it wasn't indicated. In other words, we need to figure it out. So now that means this is that's the thing that we've been missing. This is 90. Also that's 90. Okay, and if that is 90, then that makes, you know, things easier for us. So K over BD. Remember, K over BD. Remember, you always need to involve the side which is the link. Remember, triangle 1 and 2 are linked by what? They are linked by BD. So that's why I've got BD here. So K over BD, that's just opposite of hypotenuse. I mean, over adjacent. Opposite side, adjacent side, and that's equal to the tangent of theta. Alright? So, meaning that BD is simply K over the tangent of theta. Alright? K over the tangent of theta. So now that we've got BD, I think we're ready to find CD, because if you check CD over the sine of angle beta is equal to BD, right? BD over the sine of angle alpha. Okay, and this is just the sine rule. So CD over the sine of beta is equal to what? BD, it's K over tan theta divided by sine alpha. Alright, so now if we simplify, this becomes CD is equal to K sine B divided by the sine of alpha and the tangent of theta. Okay, but some of you might not understand how this came about. All right, so let's just say CD is equal to the sine of B, which is equals to K over tan theta divided by the sine of alpha. Okay, but we can change division here to multiplication. K over tan theta times 1 over the sine of alpha. Okay, so once that's changed, then we know we've got K over sine alpha tan theta. Okay, but now we've got a problem on the left hand side. We are looking for CD, not CD over the sine of betas. That's why we need to then multiply by the reciprocal of 1 over sine of B, or the multiplicative inverse. So we multiply both sides by sine B over 1, because we've got 1 over sine B there. Even here, sine B over 1, right? So this cancels that, so we're just left with the CD, which is equal to what? K sine B over sine alpha tangent of theta. Okay, and this is exactly the same as what we were asked to prove over there. Okay, and I hope you guys enjoyed that lesson. I mean, if you did your grade 11 properly, you shouldn't have any issues with these type of problems. That's literally the reason why I said, okay, let's start with the grade 11 work, and then hop onto grade 12 work, right? And because I understand very well that grade 11 is a major prerequisite for grade 12. It's just a build-up, right? So that's that, ladies and gentlemen. So we've come to the end of the lesson, and I hope you guys are going to spread out the word and tell more and more people about the value that you're getting from the channel. And peace out.